Hello, I'm Kumararaja, matrix number CN200179. So I'll be presenting my PSM1 project, that is IoT-based automated aquarium care system. So I'm from section 1, 2022-2023. I was guided by Mr. Megat Satria Zainuddin bin Yaakob. So moving on, let's go to our introduction. The project that will be developed is IoT-based automated aquarium care system. The purpose of the system is to care for the aquarium while the owner is not home or in case of power outage. So this system can support the system even though there's a power outage with the battery backup. So thus this system will automatically serve the needs of aquarium, and user can monitor the aquarium from anywhere in the world. So this feature is supported by IoT. The system will be unable to auto-feed lives without using auto-feeder, provide oxygen exchange in a aquarium using the battery-powered aerator, and then make a water change according to the user's preference. Next, the problem statement. The main factor this project is developed. A well-kept aquarium often refers to the knowledge and effort made by the hobbyist. Even though the hobbyist maintains the aquarium very well, they will not be able to monitor their fish. Thus the IoT-based automated aquarium care system will be excellent to aid the aquarium hobbyist with this. So the main reason is feeding aquatic life. Aquarists have different feeding habits according to the type of aquatic life they keep, and then leisure time, and also power feeding. There's a technique called power feeding in aquarium world. The aquarists will feed the fish few times daily to boost the growth, and then some other factors. This is where an automated feeder will be useful. The owner can set the auto feeder, the amount of time the food is added to the aquarium, and then the number of times the fish needs to be fed. Next, oxygen in aquarium. In an aquarium, surface agitation is crucial for gas exchange, carbon dioxide exchange, and oxygen. That's the reason. The bubbles released by aerator will break the surface of the water, producing surface agitation and allows gas exchange. This is a crucial factor because without oxygen, the marine lives might die due to insufficient oxygens. Then water change. Nitrate accumulates over time and one way to reduce nitrate in the water column is by changing the water. New water can also provide minerals for aquatic life, as minerals in water tend to deplete over time. Thus, the water change system will be helpful for aquarists as they can do with water change anytime and while they are not physically there. So if they are out of station and whatnot, they can this automated water change system can do water changes due to their preference without them being present. Then power outage. Almost every equipment to maintain an aquarium operates with electricity. An aquarium's worst nightmare is the power outage. Thus, this system will have a lithium-ion battery that supports the system. The system will work normally with electricity and work with battery when power outage occurs, so the system can still function normally during power outage. Next, the objectives. So the objective is to develop an automated system to maintain the aquarium's health, and then to develop a reliable aquarium monitoring system for the user, to develop an automated aquarium system that will be able to make informed decision actions on its own during critical situations without the user's presence, and then to ensure the ecosystem is in the aquarium is maintained in case of power outage. The project scope will be to use Arduino to control the system. System can auto-feed lives, provide oxygen exchange in the aquarium using battery powered aerator, and then perform water change. All this mechanism will be able to run in case of power outage. Okay, let's move on to chapter 2, literature review. So in literature review, I've added some scientific knowledge about the aquarium. the water chemistry and whatnot. So the one of the water chemist most crucial thing to know as an aquarist is nitrogen cycle. Nitrogen cycle is where the waste of fish turn into ammonia and then get nitrified to become nitrite, and then nitrification occurs also nitrified again to get be nitrate, and then if water change is water change is done, the nitrate can reduce. So there's also another photo that proves this. So we'll see it later. So nitrogen cycle is basically that what I said just now. And then I've also explained about ammonia in detail, nitrate and nitrite in detail. What happens? And then the purpose of water change, gas exchange and agitation, and lithium-ion battery and wireless sensor network is also stated in the literature review. So the purpose of water change, so why you need to water change. So as I stated just now, there will be waste, nitrogen cycle, and also we can replenish the minerals that deplete in the water column with water changes. So here, this is how an aquarium works. The ammonia, nitrite, and nitrate. The last process will be nitrate. It will always be there after the conversion. So if this exceeds, it is a dangerous level, and it might cost the fish's aquarium marine life's health. So if we do a water change, the nitrate it decreases again. So this is anode, cathode, and electrolyte features of lithium-ion battery. The materials being used in a lithium-ion battery. So lithium metal, carbon graphite, carbon hard, titanate, lithium, then synthetic graphite, tin-based alloys, and silicon-based materials are being used in a lithium-ion battery. Okay, this is where I compared the features of previous projects and current project, my project. So this project, there are 5 projects included. No, 4 projects, 4 previous studies, and then one is mine. So let's compare. So in aquarium monitoring system based of IoT, the microcontroller is Linkage 796. IoT is used. No power backup, and then auto feeder yes, aerator yes, and water change no. Then aquarium monitoring system, Raspberry Pi 3 is used. IoT is yes. No power backup, auto feeder is yes, aerator is not used, and then water change system is present. Next, smart aquarium design using Raspberry Pi and Arduino base. Raspberry Pi is used as microcontroller. IoT, yes, and then auto feeder, there's no auto feeder. There's an aeration. There's no power backup, sorry. And then there's auto feeder, and aerator is not aerator and water change system is not present. And for fish stock, Arduino Uno is used. IoT is present, and then no power backup. Auto feeder or aerator and water change system is present. So this is our project Arduino Mega 2560. So everything is present, including power backup, IoT, aerator, auto feeder, and also water change system. Next, the pros and cons of previous and current projects. So the advantages of aquarium monitoring system based on IoT is able to measure water pH, able to maintain water temperature, able to monitor system via application, able to provide aeration, and then disadvantages will be no power backup, cannot water change, and high cost. Then aquarium monitoring system able to water change, able to measure water level, turbidity and water leaking can be identified, and able to monitor system via application. There's also no power backup and aeration in this system. The next, smart aquarium design using Raspberry Pi and Arduino based, able to control system via application, has decorative lights, able to feed, able to monitor system via application, and low cost. No power backup, The disadvantages are no power backup, no aeration, and decorative lamps are only for display purposes. Then fish stock on and has video monitoring, has reverse osmosis filter, able to maintain water temperature, able to measure water pH, able to monitor system application, and able to provide aeration. There's also the disadvantages are no power backup, high cost, and complex connection. It is complex because there's reverse osmotic filter, video monitoring, so this can, and pH, water pH measuring. So this can be complex to connect. IoT based aquarium care system, our project has power backup in case of power outage, adjustable aerator, automated water change, auto feeder can be set according to preference, able to monitor via application, and low cost. Not able to measure pH. The disadvantages are not able to measure pH, not able to control water temperature, no video monitoring system, no reverse osmosis filter, and no decorative lamps. So why I did not apply all of this? Because pH, water pH, and water temperature can always be measured and controlled by the aquarist. Water pH can always be tested with test kits, and then water control, water temperature can be always you can always use an heater. If not, it is in Malaysia, the temperature is quite stable for an aquarium, so there is no need for these applications. And then video monitoring system and reverse osmosis filter, this is a very high cost system to build. So the cost of the system, the project will also increase, and this will not be reasonable for the customer to purchase, and it will be also complicated for them to understand. And then the decorative lamps you also can use with electric, can directly put it to the power supply. No need of automated systems for that. Okay, let's move on to methodology. Progress flowchart. So in PSM1, the when started, problem statement is identified, and project idea is also identified, and then this project idea is proposed to the supervisor. If the supervisor does not approve of the idea, we'll have to start again. And then if he approves, then we'll start with literature review, component selection, and then block diagram is developed, circuit diagram is developed to identify the connection and cost of the hardware and so on. Then budget prediction. This the cost of the whole product and the hardware is predicted. Then expected results and simulation is done to understand better of the components and the project. Then for PSM2, hardware development is done. If hardware doesn't meet specification, hardware development is done again until it functions. And then coding and software is done, it's developed and compiled. And then if system doesn't work, we'll have to edit the coding of the software. And then if system works, hardware and software integration is done, and report writing is also done to complete the project. The end. Going on, the block diagram. So the block diagram uses this project uses Arduino Mega 2560, and then the sensors will be water level sensor, inputs water level sensor, keypad, Wi-Fi module, lithium-ion battery, and power supply. Then outputs will be water pump, DC motor, servo, relay, LCD display, Wi-Fi module, and charger. So in the Arduino Mega, for the starting off with the aerator, there will be an output to the DC motor to run the aerator, and then for water change system, there will be an output to function the water pump. One to refill, one to decrease the water in the aquarium, and then another one to refill. Then the water level sensor, when the water is refilling, if the water level sensor senses the water, the pump stops. This is what will happen. And then the auto feeder runs with two servo motors. One will operate the inner part of the auto feeder, and then another one will open and close the valve of the auto feeder. And then keypad and display, LCD display is used to control the system manually, and Wi-Fi module to device is used to control the system or get data of the system from away from the system using devices using Wi-Fi module. And then the system is powered by a power supply. And then when in case of power outage, the relay changes to power backup, where lithium ion battery take charge of the system. Then when the power supply is back on, the relay switches back to power supply. Okay, the system flowchart. The system starts with power supply, as I said just now. If there's power outage, lithium ion battery takes charge of the system. If not, the system runs with power supply. And then if the user ons the aerator, it will operate. If not, it will turn off. So the user has the option to turn on and off the aerator. And then user set auto feeder, the times to feed and when to feed. These all can be set by the feeder, and then the auto feeder feeds when the time comes. If the feeder has to feed again for the day, it will feed again until the limit of limit set by the user is done, and then it restarts to feed the next day, and then until the user resets the system to apply new settings. And then user set water change, the water change state, and so on. So water reduced in the tank, pump 1, and then water filled back in the tank for pump 2, and then water level sensor stops the pump. This is the circuit diagram, the components used in our project. So this is a connection of Arduino Mega 250 and the breadboard. This shows an estimated connection of the circuit, where to put the connection and so on. So this is the hardware list. Arduino Mega 2506 is used submersible pool water pump, LCD display, brushless motor, and then MG5995 servo, keypad, N-channel MOSFET, and then water level sensor, logic level converter, ESP8250 Wi-Fi module, 8266 Wi-Fi module, adapter 12 1 ampere, and then single channel 5 volt relay, battery model, and rechargeable battery module, lithium battery is used. So that estimated cost for all of this hardware is about 250 ringgit, and this is only estimated. I referred to the internet for this estimation. So if I bought these hardwares in a brick shop, the price will differ. So this is the expected results. Moving on to the expected results from chapter 4. DC motor simulation was done to understand the functions of DC motor and so on. So how to code and whatnot. So here, this DC motor can be altered. The speed can be altered, and then the direction, clockwise and anti-clockwise, can be altered also. And it can be also switched off and switched on. So there's this motor driver here to drive the DC motor. So I found out this when I'm doing this simulation. So this is the coding for the simulation. Here, the pins of Arduino is put, and then here you see that the clockwise state and the digital read. So the analog changes to digital read and provides data for the Arduino to convert. So if we choose clockwise state, the analog write. So when the button is pressed, analog write happens. Digital write means the the Arduino has the data and it converts to anti-clockwise. It moves to clockwise and then else if anti-clockwise. So this is the coding compilation and verification from Arduino IDE. So the expected results of the project. The expected results of the project will be to serve all as objective and technical functionality proposed, and then auto feeders will be able to feed as preferred by users setting to, and servo motor operating the auto feeder must be able to handle the load of food and function long term. Aerator should also have to have enough power to aerate the tank and be adjusted by users' preference, and motor must also have a longer lifespan and good quality. Water change system should be able to water change the exact day the user set the system to, and water level sensor must prevent water overflow. Whole system should be able to run the system in case of power outage at least 4 hours, and the health of lithium-ion batteries should be good and long-lasting. And then the system must be user-friendly, low cost, and useful in many ways, uh, so that the user can benefit it in many ways. Okay, moving on to the conclusion. The project is expected to serve the aquarists to that they would so that they will be able to stress less of the aquarium and maintain the aquarium's health. And then project must also be a reliable aquarium monitoring system for users so that they get to monitor the aquariums from anywhere. The system should be also able to auto feed, aerate, and water change as preferred by user automatically. The system must be able to operate efficiently in power outage, as lack of oxygen and care might threaten marine life's health. That said, IoT-based automated aquarium care system should be the future innovation in the aquarium world, and this project will be developed with heart and soul to serve this purpose. Thank you.